super experts or experts who experts who basically are quite hands-on, often creating new algorithms and trying to build totally new products. Then comes analysts who actually use some of these products for deep analysis, and basically they want answers, understand the context. So these are mostly like analysts and who use the systems which are developed by the experts. And the much larger section is people who use the services, which are all normal individuals like us, and where so it's like almost everybody uses Google Maps or Uber or those kind of services. So that's where we can put everyone there. Now, moving on, just a second, I think. Yeah. Now, what makes geospatial different is okay. So what happens when you take any this is like when you take any data science problem or any statistical problem, you usually make some assumptions. One of the most important assumption is that the data which people have is what you can call as independent of each other and also belongs to identical distributions. And that's called IID assumption. Now that's something which doesn't hold true in case of geospatial data. It is and then the whole phenomena is described as spatial autocorrelation. It's as simple as this, that when you're talking about things in nature, the fundamental principle is that soil, water, when you talk about atmospheric elements, cultural artifacts like structures, languages, even cuisines, they don't change suddenly in space and time. There's continuity which is maintained, and there are no sudden transitions. So here, let's say this is a very different kind of data, heart disease, death rates. But what you will notice is that it's not that you have the darkest of the regions and suddenly you start seeing the lightest of the regions. That doesn't happen. I'm like, it's usually a trend in between. It's just like, I'm sure even in Karnataka where you are, let's say, I think Bangalore is relatively closer to Tamil Nadu. So even the Kannada language might have a lot of, the language used by people there or towards the border would be much similar to the people just across the border in Tamil Nadu. And similarly, on the other end, when you go to Hubli or other areas, the language might be somewhat more similar to people in Maharashtra. It's just like there's a continuity which gets maintained. That's all I want to try to say. So it doesn't change suddenly. We can make our borders as we want, but let's say, but the natural features are not going to change suddenly just because we made some specific border, or the way things evolved, like cultures and society are not going to change suddenly. Even the cuisines on just across the border, I'm like, those will be almost the same. But that's broadly the point here. And this is very important because most AI algorithms work with this assumption. So you just cannot use the standard AI algorithms for analyzing geospatial data. And I think that's the main point about like why we have something called geospatial AI, not just AI, because otherwise you don't need to call it as geospatial AI. Okay. Now, here's some more about like why it's different, what makes geospatial different. There's like another thing is unidirectionality of time. And what I mean by this is, let's say when you're doing any other experiment in the domain, you could change your variables. You can increase or decrease something, but when you are doing something geospatial, so geospatial data also, let me be clarified. So what I mean is like spatio-temporal data. So it's data about space and time. So what ends up happening is you cannot go back in time. You can always go further only. And so hence your analysis has to take care of that part too. So it's just a small complication. Basically, that's why like time series data gets analyzed somewhat differently than regular data. And that's part of geospatial anyway. It's just like trying to specify like what are the differences. Other things, like as I was mentioning about the language, so same way, let's say there are spillovers in other kind of data which have some kind of implicit geographical relationships. Now, I've used the examples like Gamil Chi or Caleb Singh. Basically, these names are not common, and partly Chi is a Chinese surname. Gamil is very Egyptian name. For Joao Khan, and Joao is a very Brazilian name. It's rare to find anywhere outside anywhere Brazil. Like it's, let's just say, if we think about it, in case of India, it would be very hard to find someone, let's say Hardeep Pokutti, or I'm just trying to say, let's take a very South Indian surname and or first name and just put it with a. Someone saying something?
That can we do it a little bit later?
I think someone's off mute.
I was just, yeah, 2 p.m. again, he's stuck up with something earlier itself.
Someone.
Yeah.
Hi, KK.
That is okay.
Hi, KK, you're not on mute. Could you please go on mute?
Yeah. Okay.
Okay. I'll just drop it for the time being, so that people don't get. I informed everybody in my team already.
Okay. So, yeah, on the whole, I think basically what we're trying to say is like spatial temporal data has a lot of implicit relationships like distance, direction, and requires fundamentally different models to query it, analyze it. And that's where the whole discipline of geospatial sciences has developed. Now, and it can be, I'll give you different kind of, I can give you different examples, but yeah, simple things like even identifying something is inside something else is a very different concept. It's hard to define using simple mathematical or the mathematical foundations we use in AI, which is mostly statistics. Okay. Now, some more information like, okay, what kind of analysis we typically do here is that includes, often like you do frequency. You try to analyze what are the frequency patterns or how things change over space. What are the outliers? There is a concept of spatio-temporal clusters, which means, okay, clustering in space and also around time, because some, let's say traffic for that matter, would follow a timely pattern across the day. There are peak times and so it's like things will cluster accordingly. Often a lot of crimes happen during evening or night times because it's dark and hard to see. So you can find those kind of patterns. And then you try to identify the spatial autocorrelations to be able to make sense and make predictions which you want. And it gets used in a lot of different things. You use it for disease modeling. Facility location is a very interesting problem where, let's say if a big company wants to understand where they should put their new warehouse, or if McDonald's has to decide where they put their next facility, or if a government has to decide where they should put next health center for serving the people. Now those are calculations which has to be done by making a best prediction about what will be the total coverage area it can take. And now coverage could also depend not just in terms of population, it can also be about timely access, because if you're thinking about emergency and you don't want anyone to be living more than half an hour away from a health facility, it's a different kind of optimization which you need to do to identify the location. And I think Neil had mentioned somewhat similar problem about water, about the distribution of some chemical for water treatment in Punjab. Neil, is that right? I think where probably like identifying the best locations from which the distribution of that chemical could be done is the problem they wanted to solve, and I think you guys are working on that. So anyway, a lot of problems get solved using these techniques. Another thing which has been changing in the geospatial world is a lot of problems have become such that people expect real-time results, especially like navigation. When you are asking Google how to go from point A to point B, expectations have totally changed. Otherwise, it could have. It's a problem which technically could take a lot of time, but now we expected the answer within a second. So that's also changed. Now I'm just starting with some examples. So here's like a mapping algorithm, which some of my colleagues have developed. And so here, like we used in the beginning data from phone traces. So people who are in vehicles, and so in the blue you see their phone traces based algorithm. So when you have enough of phone traces, you could actually map the location. So we didn't have the map. We just created a map using phone traces, and then we use another algorithm where we use the satellite imagery, and we in a way created a small AI agent kind of thing, which is almost as like an individual like, going across, going and exploring different roads, and hence creating the roads incrementally. So it was iterative road network mapping algorithm which we had developed. And so this is just to give an example that because mapping is one of the biggest problems in geospatial AI. You can say mapping is kind of solved, but then all kinds of maps are there. So just and still, like even road maps are not fully updated all the time. Even today, all the companies have been investing a lot in updating their maps all the time. Now, here's some use cases I just wanted to identify. Let's say, I just try to categorize like for risk, you could do damage assessment after disasters, and that's there's a big. That's one of the places where like satellite imagery is being used a lot nowadays. A lot of these examples are around satellite imagery, partly because that's a very fast growing data source in geospatial nowadays. Let's say, similarly, traffic is another big problem, which around which a lot of applications are made, whether understanding how the traffic will work, or even managing, let's say, fleets on the ground in real time. I'm like, if you have 100 trucks and one of them met an accident, then you also need to be able to figure out, okay, how do you cover up those routes which it was supposed to serve? And also just like things can change dynamically. So you can't go, you need to have a plan, but your plans can also keep changing in real time based on traffic, based on some other accidents, other events. Anyway, some other applications include, let's say, in case of environment, people have been using it to even count trees, or at least count the coverage area of trees and all. That's usually, so the coverage area in general gets classified as land use classification, where you're trying to understand how much area is farms, how much area is urban settlements, and how much area is forests of water and water bodies. Water body monitoring itself is a big problem because yeah, like freshwater resources are drying up. So being able to track all the sources and their current state is quite important. And how do you do it automatically rather than trying to get ground data? It's like you won't be able to find people doing the measurements from ground all the time. So that's one of the things. So different kind of problems people are working on. You can even identify specific crops, the field, and it's just to give you a blend of like what all kind of applications people are using these things for. Am I on time, or like how does it?
Yeah. We're faring pretty well on time.
Okay, so here's like one application I proposed to someone. This is interesting in a sense, like this is about using in case of disasters, how do you respond using social media? And okay, some of it, let us say, I'm sure in April, May last in India, at least, we all know that almost everybody was on social media asking, okay, you need somebody needs a bed, somebody needs this medicine, and yeah, it was a disaster. Sorry, it was not a natural disaster, but then we know that so much of information was getting exchanged. Now, imagine if we have a system which could automatically take all this data, parse it, that okay, where a particular request is coming from. If not, maybe do a verification for further to place the location, and then also remove the duplicates and map it in a just map it in a way. I'm like, so that people can get it. I don't want to get into what it means by analysis ready data and this is info. But yeah, broadly, if people who are in some kind of control centers or command centers, if they can get all that information in a dashboard, then which is map based, they could actually take decisions, and the information is coming in real time. So that's the kind of system which can be made. And there are people who have been trying to build such things. It's not like it's not a novel idea from me. It's like we proposed it recently somewhere. So that's what I thought I'll just include this slide. But yeah, so this is a very real use case which can help people. And I guess at least after the last April-May scenario what happened in India, I guess almost everybody can understand, yes, this could be helpful. Because a lot of people who are volunteering time, even in my friend circle, were just trying to go through the requests and trying to understand, okay, how do you match them together? If the matching can happen automatically, that's a big deal. Okay, so good. So, like another thing, I felt this might be of interest to you guys, which is in the US and some of the developed countries, this has started happening. It is like municipalities or cities would try to use satellite imagery to understand, to do what they call as automated change detection for building surface areas, etc. So basically to calculate property tax using that. Now, is like they'll look at what is the image before, and if the after image is additional construction, they'll try to classify it as construction which was done without notifying the authorities properly, without proper approvals. So hence, you could calculate that. And this is, yeah, I'm like, it could be hard, but I just wanted to put like this another picture. So this is from a World Bank document, I think 2018, or maybe. Anyway, so in that case, like they used, so this is for, this image is from Kigali in Kenya. So there they used satellite imagery to calculate property tax. So, okay, maybe because the imagery wasn't as it's not very high resolution imagery, but still they managed. And here they tried to build a model which could also try to figure out the height of the buildings. Because often in developed countries, when you have dense locations, it's the height where people are growing, increasing the building area, and that's the concern. So it's just like at least gives you a pointer that, okay, these are the places where you one should go and look at, where probably another floor has been constructed, or floor or two. And so it's not just developed countries, even in developing countries, it's useful. So that's the whole point. I mean, yeah, because sometimes it feels like something in developed countries might not be relevant to us, but it is actually. I'm like, other thing is like, even if you have crowdsourced photos of illegal construction, maybe from jealous neighbors or whatever, that could also, if it's geotagged, you could use it for that. So I'm like, you can make different kind of models, but that's possible. I think this is another thing which might be of interest because of the water problem I was told about earlier. And so this is, I found some paper from, I think some people did this experiment in Uttarakhand, and they, so here, like actually these are photos taken from smartphones, from which they calculated whether the water is turbidity level of water, to be able to say that whether water is clean enough or not. Yeah, you can try to do the same using satellite imagery also, wherever available. So it's a possibility which can be explored, at least to calculate, to understand, okay, whether the water is clean enough or not. And so when it's not, then it's quite clear. When the model says it's clear, then you may have to still go and do further tests, because there could be things which are soluble and still keep the water clear, but may not be healthy. Anyway, there's more work to be done, but then you could still get enough of good starting points. So that's another use case I thought you guys might like. This is another one, which is, so some of my colleagues developed this algorithm, and they, so this is about like accident risk prediction, like where accidents can happen. Now, in case of India, I think so. Even in developed countries, you find that you don't have enough data on where accidents have happened to calculate any kind of risk. Hence, either planning authorities could try to take any action that, okay, can we do anything at that place, location, so that the risk of accidents could decrease, or maybe even insurance companies might be interested in it. But so that doesn't exist. So there's very sparse data. So what they used was like another geospatial concept, which is similar places would behave quite similarly. And like these are very intuitive things. It's kind of common sense, but again, AI, for all we say, is not that intelligent. So how do you bring that kind of intelligence into this? Like you have to train your models in a specific way. So they ended up doing, okay, you tried to identify locations which are somewhat similar in a satellite imagery. They use satellite imagery, OSM maps, and some of those other data. And then together they fed it to a model which learned, okay, these locations seem similar and vehicles behave similarly here. Hence, even if it was not, there was no accident observed in really recent data, you could still predict that, yes, there would be accidents. And they did some testing on some of the data. So let's say they were looking for data up to 2 years back, and then they know that using that, the model predicted that there are 4 more, in this case, let's say there are 4 more locations are being shown where accidents can happen. And in the next 2 years data, which they already had, they did notice accidents happening there. So it's just like a validation that, yes, algorithm kind of was able to identify locations where crashes can happen. So apparently, okay. So that's the term which typically policymakers prefer. I wrote accident. Yeah, it's usually crash is the word they prefer. Anyway, that's how it works. So other than that, at a high level, okay. So there's, in terms of GeoAI trends, what we are seeing is right now what happens is more along the lines of object detection, where like people are able to detect things like whether there's a farm there, a building, or some kind of asset. Asset means it could be even, we say, vehicle and all. I can give you examples like that also, but yeah. So that's where we are right now, and now things are moving a little bit towards the predictive stage, where so we have defined like, okay, 3 stages: descriptive, predictive, and prescriptive. By predictive, what we mean is like it can actually estimate, okay, based on the way things are changing, within some time, let's say there would be this kind of damage to the crop, and which could include, let's say, this kind of pest damage to crop. So okay, so some things which you can see visually in a crop are different from so the crops at the before you could see a pest or any disease sign visually. Even before that, it starts emitting some other what you can call electromagnetic signatures in a way, or some other materials or smell kind of things, which will have a different electromagnetic signature. And when you use satellite images, so not just the visual band imagery, there's a lot of other electromagnetic bands for which you can get readings when you're using like multispectral or hyperspectral data. You could actually predict when you could actually identify those patterns before it, which means like you could identify those potential crop damage well in time. And which is where, so right now they're moving almost towards being able to predict the damage, but the next stage where within 5 years or so, where people want to reach is to be able to say that, okay, using a hyperspectral imagery, we identified that your crop is at the high risk of damage from this, which is already infected by a particular pest or something. So use this pesticide and do it. So it's just like what exactly needs to be done will also be systems will also be able to predict. This is where we are moving, and these are not far-fetched things. These are like 4 or 5 years. They will pass very fast. At the same time, the other thing which is happening is the geospatial data in general has been increasing in both quality, variety, coverage, frequency, all the dimensions we can talk about, while the cost of acquiring geospatial data has been falling like anything. So that's, and this includes even data from satellite imaging. Number of satellites which were okay by the study, okay, around 2020, or even like between mid 2021, there were around 2,300 satellites in orbit, whereas the projections are that by 2030 there would be at least 10,000 satellites in the orbit. So is it just the number of satellites are going to expand like anything? And this is 2,300 is like since the beginning of this whole satellites getting launched, we have these many. And the next 10 years we're expecting, or 8 years we're expecting almost 3 times more coming into orbit. Anyway, so that's I can actually kind of stop here, or maybe let's just say I have some more slides, but as I mentioned about the crowdsourced, one of my strong interests right now is that we have a lot of people. Okay, so this is just a random thing from Spain, but where people are using some of this Waze data to collect traffic information, whether is there some route construction or diversion happening, or traffic status plus accidents and all. But this is like crowdsourced information, and I just wanted to see that there's a huge amount of potential in using crowdsourced data for governance, and yeah, a lot of governments are also looking at it. But I think that's that's where my focus is going forward. And yeah, if we, I'm definitely interested in trying to figure out if we can do something together on this front, because I think this, like when I was mentioning about that COVID data, COVID dashboard thing, which or the disaster dashboard thing I showed. So there, again, it's crowdsourced data because people are providing the data. You're not going and collecting it manually yourself. But so that's, or for that matter, any kind of user-generated content can be called as crowdsourced data if people have given you permission to save that data. So how do we use those other new sources of data to enable better governance? That's all. I'm like, or what you can call in your language as a citizen-centric governance. That's the high-level thing. I do have some other presentation, like I have some other slides, but yeah, I guess I can stop there. So yeah, wait a second. I think if you want, I can show you. I'm like, okay, I'll just show you this one. So this is about AI's limitations. It's like, this is a very somewhat old picture, 2000, almost 10 years old, but yeah, like even then the problem was there. Like if you ask an AI algorithm how many people are there or why people are laughing, it cannot figure out. So that's, so there are a lot of things which AI cannot do. So it's like we need to know that the simple thing, like because AI cannot figure out that there are mirrors and the people in the mirrors are going to be same from different angles. Is it like, or there's a weighing machine on which President Obama has put his foot, and because of that, this other guy is confused, like why his weight is it like, it's funny to everyone else, but not to this guy. So it's there's a lot which AI cannot do. So we need, and not much has changed. See, this is 10 years back, somebody posted, Andrika Pati is the Tesla's head of AI. He posted this 10 years back, and even today, we are still at this place only. AI cannot solve these problems. Okay. It's not very different. Just to give you an example. In fact, like I'll give you, so this, another like, okay, let's say in case of how the geospatial element comes into play. So Google is the best, or as the biggest AI company in the world in a way. And if you say, if I ask you a question, what is the distance between Gujarat and Rajasthan? Like, okay, these are border states. So a normal common sense answer is there's no distance. Like they are across borders, but then you ask Google, it will give you a distance. Okay. But this is, it just assumes Rajasthan to be a point, but it's not a point. It's a whole area. It takes the center of that centroid, whatever you want to call. Similarly, you could do what is the distance between Gujarat and India, or maybe Delhi and India, and it would still go and give you some distance. which doesn't make sense because Gujarat is within India. So this is like simple, let's say geospatial, simple common sense concept, which you and I or even a kid can understand, but AI cannot understand. And this is Google, like the biggest AI company in the world. So, so that's where we are. So not everything can be done that way. Like there's a lot where we'll need human inputs, and that's where I think we need to figure out how do we use crowdsource inputs and machine algorithms together to make the best out of everything. I guess. Anyway, I have some more stuff, but that's fine. I think we can stop here.
Okay, thank you, Lokendra, for that interesting session. We'll now open up for questions and answers. I see folks have already come in with their questions. There's a question from Naveen. I'll read it out loud. Or Naveen, do you want to unmute yourself and ask this question yourself?
Yeah. Hi, Lokendra. Thanks a lot. That was a very interesting talk. This is specifically with regards to some project in which there is a government agency trying to use drone imagery for kind of doing analysis, and the feedback that I got from somewhere was that satellite imagery is costly and things like that. So it is like one is the cost relationship between the two, and accuracy and data accuracy and quality of data in both the cases.
Yeah.
So that we want to understand.
Okay. So it depends. Okay. So what kind of analysis it is. So if it's an analysis which doesn't require very high resolution imagery, then there are some sources of satellite imagery data which are free. But then that's like the best you will get is 10 meter per pixel. So 1 pixel equals 10 meter by 10 meter area, where almost like 100 square meter area. Whereas and most others are usually around 30 meter per pixel kind of. So it's 10 to 30 meter pixel range where you'll find a lot of free imagery from NASA or European Space Agency, etc. So those are the big space, what you can say, satellite imagery data sets which are free. And even again, so when you're just trying to understand at a high scale, okay, what percent, how much area is covered by forests, how much area is built up area, urban area, those kind of things, so which is called, let's say, land cover, land use kind of stuff, then that's fine. But if you want to be able to do the area calculation I was showing for this property tax thing, now that's something where you need high resolution satellite imagery, and those are not free. So that's where, again, the rates vary from $10, $12 per square kilometer to probably, I think, $15, $20 per square kilometer. And now there's again another issue, which is which you normally won't face when you're getting data from drones. Is so the drone data could have an accuracy of around 1 centimeter also, because you're taking the image from a much lower altitude. You're just above the building, so it could even be millimeters. But let's say usually 1 to 5 centimeter is the accuracy most of the drones give you per pixel. So that's your data is, in a sense, like the picture quality is much better, plain and simple. Now, other problem which is there with satellite imagery is like often you'll find clouds, and that's something you can't get rid of in case of satellite imagery. The only thing what they do is, let's say, when they have taken a lot of satellite images from the same location, then they are able to stitch together a full image from different parts wherever clouds were there. So this is like, but then that's a artificially made image, and so sometimes that's why they take like usually multiple. Often, see, in case of high resolution data, right now there's no big database where you can get data directly. Like companies like Maxar and Planet Labs, they have their own data sets, but they don't make it available easily like that. So what ends up happening is, or most often, like people are also looking for most recent data. So that's where you have to task it. So you basically task a satellite with a camera to take photos for that location. So when it reaches that location, it starts taking photos. And if your luck is not good and there are clouds in between on that day, then whenever it comes back, and often most of these satellites have a 12-hour revisit cycle. So it's like they take 2 rounds of Earth within a day. So they'll take another picture after 12 hours, then again after 12 hours. So they usually end up collecting I remember in one case for us, it took more than 7 days to get a somewhat clear picture, just because of cloud. So that's other issue which happens in case of satellite imagery. But yeah, if you start comparing the cost in that sense, if you're able to get some data, let's say at $12-15 also per square kilometer, so that's going to be way cheaper than drones. But often satellite imagery, they would be giving you the minimum coverage area will also be there. So it could be, let's say, 25 square kilometers is the minimum you need to buy. So it's not just, so you're not buying 1 square kilometer, you're buying 25 square kilometer. They're giving you a patch, which some of the area you may not even want. Yeah? Even if you wanted 25, it could be, it's just like, it's just the way their cameras work and whatever overlaps they get, they'll be selling you that kind of data in that format. So the costs start adding up in that sense. But I think cost of getting data through drones are definitely higher. It's just that cost of getting data, the quality of drone data is definitely much better. There's no doubt about it. Quality, accuracy, whatever you want to call it. And also, if you just need a small amount of data, then there's no point of tasking satellites to collect that data, because they'll be collecting a lot more data than you need.
This question was specifically with respect to one is property tax evaluation, like basically this, and the other was in terms of solid waste. We are talking about identifying the black spots in a town. So this is specifically with regard to that kind of problem where the proposition is to use a drone data. And what right now the confusion is that can this whole process of collecting data from drone can be automated?
So I think, I would be biased towards going again, property tax collection data. So let's just do it stepwise. What I would say is, if you could figure out, okay, it may take some investment by those parties and all in the beginning, but what can happen is, if all the time you're trying to collect data everywhere using drones, it's going to be very costly. So what you really want to do is, if you could do something like a change detection system, where a satellite could actually satellite could identify places where it thinks, so your model can identify that, okay, using satellite imagery, which is relatively, let's say, if you have already tasked for specific city and all, overall cost could be very nominal, because so the whole city is getting data is getting collected fast. Now your AI model is able to tell you these are the location where it expects change. And if you're using, let's say, I can tell you, let's say, Planet Labs has a service which is around 5 meters per pixel, so which is not bad, but I'm not so sure whether in case of India we can find enough different change in that. But let's say if you are able to use somewhat medium resolution data to identify where the change has occurred, and then task drones to go collect more. So change data, change detection can help you identify where to go get drone data from. Otherwise, if you are in dark and you don't know and you're trying to collect drone data from everywhere, that's a big problem. So that's if you're thinking of making it automatic. Other ways, like if you're getting any other data from ground, where like whether the neighbors have complained or someone else has said anything, and you're sending drone, that's a different thing. Then you have a more reliable source of data. But when you don't have any source of data and you're just trying to identify where some changes happen and hence send a drone there, you could actually optimize on your cost if you use satellite imagery with drones. But yeah, if you want to actually calculate how many square foot has been built extra. That's where I think drones would, yeah, you could use high resolution satellite data also, but then if it's only about one home in that location, then that's not going to be worth the amount for, I think it's just the cost optimization problem finally. So you can look at that way. But overall satellite imagery for the for the area would be cheaper. It's just that if you don't need the other areas, then how does it work? So that becomes the problem. I mean, like, it's, I can understand why somebody would want to use drone, because yeah, that's in a way highly reliable, but finally it would be much more costly. And if you don't know where, then and if it's a government entity, chances of corruption getting in, and those guys are saying, okay, we'll do regular sweeps and give you data only when there's some change and all. I can say, okay, it becomes a multi-crore business very fast without anyone even noticing like what's happening. So it depends on the objective. If they are pushing for drones, is there any other agenda or not? I don't know.
It's a very interesting insight. Thanks a lot for that.
I'm like, see, if you are, again, if you are in the administration, and if you have connections, if somebody is able to, if you know that, okay, I can get, I don't know, like, you know how things work in India. So if there's any other angle where people are making sure that there are some drone contacts they can secure, then that's a very different game. But to some extent, you can collect, let's say, whatever you can see from sky, that kind of data you can collect from satellite imagery. In fact, I think Maxar provides 30 centimeter, which is like 1 foot per pixel data. So that's, I don't know the exact pricing for it, probably around $20 per square kilometer, but I'm just saying, so those things are available. It's just like, yeah, whether you get clear image or not, some of those problems might be there. But how, my take is that usually property tax calculations happen once a year, and then you have to, those are the dues and you have to submit. So I don't think there's so much of immediacy issue here. Drones can definitely address the immediacy issue very fast. Yeah, let's say if you see some illegal construction and you want to, you score it, you notify the authorities, and the encroachment officer goes and removes that structure. That's a different game. Before it, you know. So again, that becomes the use case. Like if drones are being used for policing, drones might be much more useful in that sense, because they could be much more real time, but then the cost will be more, no doubt about it.
Okay. Thanks.
Great. So
okay,
we are only
there's one question. I think you mentioned should go back in time in geospatial analysis.
Yeah.
Okay, so this is okay. What I meant was, you, let's say in chemistry, when you do an experiment, you could increase or decrease an ingredient, or let's say you are in marketing, when people are looking at what people are responding to, they will just increase, let's say, okay, focus on this thing or do that. They'll change their variables, increase or decrease, and can play around with it. But when you are working with spatio-temporal data, or when you have basically any kind of time series data in that sense, you actually cannot go back in time. Like whatever has happened now, the next thing has to happen on top of that only. So if, let's say if a bridge got broken, now there's no way to go back in time, because time doesn't go back. You know, so time only moves in one direction. So that's the issue. It's like, so the analysis cannot use those kind of scenarios. Okay, what happened now? The next thing only can be figured out. Like how do you fix the bridge? Not that you go back in time. It's just that we can't time travel. That's all.
Okay, got
So
it.
it's just like it has to be analyzed differently.
Okay. So we are almost at time.
Yeah.
So first of all, really thanks a lot for taking us through that interesting overview of GeoAI. I think what I'd request of all the functional and the mission leads is to maybe think internally in terms of what could be potential areas where GeoAI could be useful, and then do reach out to me, and then perhaps either we could explore internally, or we could also engage with Lokendra further on those use cases and see how GeoAI could be made. We could take advantage of this these techniques. And Lokendra, I'd reach out to you again. We are setting up some open data strategy, and we would request your inputs on some of those initiatives also, because with our impetus on open source development, we are also looking to engage some of our volunteer and bazaar partners in ensuring that the development of solutions and roadmaps on the platform itself are also made open. So I'll reach out to you on that thread.
Sure.
Again.
That's fine. So I hope I made some sense.